Hi, my name is Adam Leftick. I run the product management team for Oracle GlassFish Server. And today I'm going to be talking about Active Cache, which is a new feature in 3.1. One of the things we're going to do, in the first part we're going to cover the actual concepts as well as some of the details on Active Cache. Then we're going to move into, on part 2, an example of how you actually go about configuring and deploying Active Cache for GlassFish. So in this talk, at least in the first part of this series, I'd like to start off and we're going to just sort of describe the Active Cache feature set, and primarily we're going to focus on Coherence Web. And Coherence Web has a number of concepts that are useful for understanding before you go about actually deploying a Coherence Web solution. So we're going to drill down on deployment models, the various session models you can configure, locking modes, the cluster node isolation configuration, as well as session attribute sharing. And then lastly, we'll just describe how you go about integrating this solution with Oracle GlassFish Server 3.1. So Coherence Web is a in-memory state replication replacement for the Oracle GlassFish Server HTTP state replication services. And a lot of people ask the question, why would you want to replace it? So there's a number of reasons why Coherence Web can add value to your environment. Often, as applications scale out and you have lots of state in HTTP sessions storage, you effectively want to be able to decouple the session management from the web container. And this allows you to handle a larger number of users without adding more application servers, because you're going to independently scale out the HTTP session state storage from the actual application runtime. This also, as a result, decouples the lifecycle of the actual application server from the underlying state management of the data itself. And Coherence Web provides a number of mechanisms for handling very large sessions more efficiently than the existing HTTP state replication. Then lastly, we introduce a number of new locking modes that are available as part of this solution. And this allows you to ensure that your HTTP session data is always up to date. So let's drill into some of the Coherence Web deployment model. The first deployment model we're going to talk about is called the in-process model. In the in-process model, we have a cluster of Oracle GlassFish Server instances. And the Coherence cluster service is going to run in the same JVM as the Oracle GlassFish Server application instances. Now, this means that all the session state are actually going to be stored on the heaps of the Oracle GlassFish Server. So, in this model, because of that, we don't actually recommend it for production use. However, it's simple to get up and running for demonstration purposes. You just set a few flags and deploy. Now, the first sort of production model that we're talking about is called the out-of-process model. And in the out-of-process model, you have two tiers. In the first tier, you have your traditional Oracle GlassFish Server cluster. And in the cluster, you're actually not going to store HTTP session data. It's going to delegate the storage of HTTP session data to a new tier. And in this tier, you're going to have a cluster of Oracle Coherence cache servers running that will be used for offloading the storage of HTTP session data. Now, the beauty of this model is effectively you can scale each tier independently. You can add more Oracle GlassFish Server instances to handle more application load or more application requests. However, as the number of user increases and you need to store more additional state, you can increase the number of Oracle cache servers. In the third model, we refer to as the out-of-process extend model. The out-of-process extend model is useful for environments where you cannot effectively run UDP traffic, which is the primary protocol that Oracle Coherence clusters rely on. So in this model, you set up a subset of the Oracle cache Oracle Coherence Cache Server cluster to run the extend service. And the extend service will expose a series of TCP/IP listeners that the Oracle GlassFish cluster can connect to. This model is also useful if you want to partition the actual Oracle Coherence cluster from the application server cluster. And this can be sort of advantageous for environments where you're constantly bringing up and down Oracle GlassFish server instances and you don't want to disrupt the state storage cluster. It's completely isolated in this model. Now let's talk a bit about some of the various session storage models that they have in Coherence Web. So the first one we're going to describe is called the traditional model. In the traditional model, this allows you to configure the storage of HTTP session data through discrete attributes. And in this case, when each attribute that you store in HTTP session gets serialized and deserialized separately. And this is pretty consistent with the way a large number of application servers tend to implement their internal HTTP session replication. Thus, we refer to it as the traditional model. The other configurable model we have is called the monolithic model. It's similar to the traditional model. However, in this case, we serialize the entire HTTP session object as a unit. All the attributes are serialized as the unit, and therefore you pay the overhead of serializing the entire HTTP session anytime you change an attribute. However, what it does do is if you have a large object graph with a bunch of related objects, you don't create copies that would result from individual attributes being serialized and deserialized. So this trades that sort of memory size for performance. But definitely if you have a complex large object graph, this might be advantageous to configure. The third model we're going to describe is called the split model. Now, it's similar to the previous models. However, what we allow you to do is partition the individual session attributes based on a attribute overflow threshold, which is a size. And so basically, this allows you to set small, frequently accessed objects in one session storage cache, and then larger binaries, say larger objects, into a second cache. And this basically allows you to come up with different cache topologies as well as leverage near caching for small attributes, but then also push larger objects to a different topology. Now, let's describe some of the various locking modes. This is a pretty unique feature to Coherence Web. In the optimistic locking mode, what this means is we allow any member in the application in the Coherence clusters to access and update a HTTP session object simultaneously. However, if a multiple instances were to update the Coherence cache server, we'll reject any updates that had occurred out of band. And so this is very similar to what you have in optimistic locking models on the database side as well. Now, member locking is much more restrictive. This allows only one Coherence cluster member to update a HTTP session data at a time. So in this case, the client or the application server must explicitly get a lock to the underlying cache entry, update it, and then release the lock. While the member has the lock, no other cluster members can actually update the same HTTP session data. Now, thread locking, the third locking mode option, is even more restrictive. It doesn't allow multiple threads of execution in the same member to access the HTTP session object. So in this case, the individual thread of execution creates a lock. This can be useful potentially in environments where you're using frames or AJAX, where you have multiple concurrent threads of execution or multiple concurrent HTTP requests that result in multiple threads of execution accessing an HTTP session object. And I think this is a pretty unique feature. Now, obviously, for performance reasons, optimistic locking is going to provide you the most throughput, and you'll get the most safety with thread locking, of course. One thing to remember about member locking, we'll talk a bit about this when we get into cluster node isolation, is that a member, the sort of cardinality of members per JVM is sort of defined by the class loader architecture, and we'll talk a bit about that later in the talk. Now, cluster node isolation. So what do we mean by this? Well, the coherence cluster service is class loader scoped, and therefore each member is defined by the cluster service. So if you have multiple cluster services running in the same JVM, you will have multiple members in a single JVM. So the first type of cluster node isolation that we're going to talk about is called application server scoped. In this model, effectively, we have one member per JVM, or one Oracle cluster server instance. And the way we do this is we push the coherence.jar file, which contains the classes that are responsible for the coherence cluster service, into the server's class path. And if we deploy multiple Coherence Web enabled applications to this Oracle GlassFish server, they'll all share the same cluster service, resulting in the smallest number of members, 1, that is possible for a deployment. This also has a nice benefit of ensuring that you only have one copy of the coherence classes in memory, literally one instance of the coherence.class files per JVM. The downside, of course, is that the lifecycle of the cluster service is effectively shared by the entire applications, by the entire number of applications deployed on the server. So, for example, if you shut down a web application or an ear, or you shut down the cluster service, it'll affect all the other web applications running. The second type of cluster node isolation we'll describe is called the ear scoped. In ear scoped, effectively what we do is we package the coherence.jar, and thus the cluster service implementation, in the ear class loader, and this is typically done by placing coherence.jar inside of the lib directory of the ear file. This results in the smallest number of coherence members, assuming you're deploying more than one ear with a war contained to a server instance, and it also results in no changes to the server's class path, which can also be an administrative hassle for some folks. For example, you copying coherence.jar into every lib directory, GlassFish lib directory, can be administratively challenging. So this provides a sort of solution there. Now, the downside, of course, is that you'll have multiple instances of the coherence cluster service, and you can have multiple instances, or multiple members, rather, in the same JVM if you have multiple ears deployed with multiple coherence web applications. Now, if you only have one ear that contains multiple WAR files deployed to Oracle GlassFish server instance, then effectively you have the same sort of construct with a application server scope. So one thing to remember is if you're only deploying one Coherence Web enabled application to Oracle GlassFish server instances, the difference between the cluster node scopes become meaningless. Now, cluster node isolation for the last model we'll talk about is the WAR scope. And in the WAR scope, we effectively push the cluster service into the web application class loader. And so this results in potentially the largest number of coherence members in Oracle GlassFish server deployment. And therefore, all the resources associated with the cluster service, like threads of execution, etc., as well as instances of the coherence class files themselves, or classes themselves. So you have to sort of be careful in the depending on if you're deploying a large number of web applications to an Oracle GlassFish server, and you're enabling Coherence Web on most of those applications. Now, the benefit of this, of course, is you get complete control over the lifecycle of the cluster service, and it's completely tied to the actual web application you're deploying. Now, again, if you're only deploying one web application to Oracle GlassFish server, this effectively has the same characteristics of a ear scoped as well as a server scoped. Okay, now let's drill down on session and session attribute scoping features of Coherence Web. So in the out of the box, we provide a couple of different session scoping configurations. Now, because of the nature of Coherence Web, we allow users and administrators to configure the Coherence Web environment to allow multiple web applications to share HTTP session data. Now, for those of you who are well versed in the servlet specification, will note that each web application that's deployed to a servlet engine must maintain a separate HTTP session context, or excuse me, servlet context, and that servlet context defines how sessions are scoped. So you can't share scope, basically. Now, Coherence Web basically allows you to deploy a session sharing model where you can effectively share state between multiple applications that can be deployed on even different actual web containers. Coherence Web is supported on a number of servlet engines as well as Java EE application servers, including Oracle WebLogic Server, Oracle GlassFish Server, Tomcat, JBoss, IBM WebSphere. And with the global scope controller enabled, effectively what this allows you to do is access HTTP session attributes from a different application. Now, obviously, the namespaces have to be unique, and if they collide, effectively you can have one application overwrite another application's HTTP session data. So that's something you definitely have to be careful of. Now, we actually provide a interface that you could potentially override if you wanted to provide a session mapper in the scenario that I described, where you had effectively namespace collisions that you wanted to deal with outside of the applications. You can implement your own scope controller. And of course, the global scope controller that we provide out of the box allows you to share state across applications, and then the attribute scope controller is designed to be consistent with the servlet specification, which forces the attributes to be shared only by the application. Okay. Now let's dive into some of the installation details. Now, it's going to be a bit complicated, so I'm going to walk through this fairly close. So, now there's two options with Oracle GlassFish Server. The first option, and this depends on which version, is called the SPI-based installer, or Active Cache for GlassFish. Now, this provides a very tight integration with Oracle GlassFish Server 3.1, and this is a new feature, and it's only available on Oracle GlassFish Server 3.1 and above. And basically, this provides a complete drop-in replacement for the state replication that exists in Oracle GlassFish Server out of the box. Now, this first deployment option basically is very easy to set up, and I'll sort of describe what you have to do, but effectively you don't really have to change the application at all. The second deployment model is supported on older versions of GlassFish Server that aren't based on the Servlet 3.0 spec. And this is referred to as the generic J2E application instrumentation. And this is done via the web installer. So if you're using GlassFish Server 2.1, effectively what you'll do is you'll run the web installer and you'll point it to your ear file, and it'll re-instrument your ear or WAR file for deployment. Now, a couple things to remember about the Coherence Web or Active Cache for GlassFish Server, which uses the SPI-based deployment. One, there's no single actual software distribution for this. So it requires you get Oracle Coherence 3.7, which includes Coherence Web. And in addition to Coherence 3.7, you need to get a distribution of Oracle GlassFish Server 3.1. And so it's only supported on Oracle GlassFish Server 3.1 and Coherence 3.7. So At a high level, these are the sort of installation steps. The first thing is if you're shipping with Oracle, what ships with Oracle GlassFish Server is a module called GlassFish-Coherence Web-glue.jar. And this really provides the SPI-based implementation for Coherence Web. The second step is you have to include Coherence jar in the server's class path if you're going to be using the server scoped or server scope node isolation. If you're not, then you would package it in your application, either in your lib directory or in your web inf lib directory if you're deploying a WAR file. Then you're going to package up your application and deploy it to the Oracle GlassFish server, and the cluster is optional, and I'll try and talk a bit about that in the end. Then you're going to start up a cache server tier running Oracle Coherence cache servers, and then you're going to deploy your Coherence web-enabled WAR or ER file. Okay. Obviously, you're going to have to do the deployment. You must start up a Oracle GlassFish server instance. Now, the cluster, whether or not you choose to deploy it to an Oracle GlassFish server cluster, is really up to you. The cluster ware for Coherence is completely independent of the clusterware for Oracle GlassFish server. And this has some benefits as well as effectively allowing you to scale out the Coherence Web implement or clusterware independent of Oracle GlassFish server's cluster. The downside of not deploying it to an Oracle GlassFish cluster is that you have to configure many standalone instances potentially to deploy your application to. So generally speaking, you're probably going to want to use Oracle GlassFish clusters as a mechanism for configuring the GlassFish environment for Coherence Web. Now, configuring a Coherence Web-enabled WAR entails effectively providing a entry in your deployment descriptor, the proprietary deployment descriptor in your web archive. So if you can, new to 3.1 is the glassfish-web.xml, or you can use the previous sun-web.xml. And in there, you effectively define a HTML fragment here, which enables the Coherence Web by telling the session manager that the persistence type is Coherence Web. And so once you do this, it'll effectively look in the class path for the coherence-web.jar file. And so the simplest mechanism is providing is to provide the coherence web.jar in the web inf lib directory of your WAR file. So this is the other step. Now, one step that's actually not on the slide you also have to do if you haven't packaged the session cache configuration file, which basically has the topology configuration for Coherence Web. So that's another step. Now, if you're using Coherence clusters for storing cache data as well, you may want to customize that file. So you would configure that as well. So that's why I didn't include it on the slideware. Now, if you're using an older version of GlassFish and you want to use the generic J2E instrumentation, or the web installer as we call it, you effectively will run this against your WAR ER file. It'll generate a coherence-web config file. It'll wrap all the servlets, the servlet filters, extend all your JSP files with the appropriate Coherence Web implementations to delegate to effectively delegate storage to Coherence Web. It also provides some default configuration settings for Coherence Web and packages them into your WAR and ER file. This is the generic J2E application installer or instrumentation is pretty invasive. So generally speaking, if you're we try and shy away from it unless you have to use it on GlassFish Server 2.1. It's actually not supported on 3.1 at all because the generic J2E application instrumentation, at least as of version 3.7, doesn't support the Servlet 3.0 spec. Okay, a couple of tips and tricks for those of you out there. By default, the cache configuration includes a -d Tangasol coherence session.local storage attribute to be overridden for enabling storage enabling the session storage service. So you want to set this on every storage enabled cluster member on the JVM for every storage enabled cluster member. The other thing I talked a bit about earlier is that the coherence clusters have nothing to do with the group membership service or shoal clustering in general. It's completely parallel or orthogonal cluster to what's going on with coherence. The other file I mentioned already as well, and it's very important, is the session-cacheconfig.xml, which defines the coherence web topology. So if you want to make changes to the topology structure, then you would basically edit the session cache config. The other option there too is to provide your own cache entries there if you're using a coherence for storing things in named caches, for example, if you're just using coherence for distributed caching or data grid functionality. Lastly, the web.xml actually contains quite a few, well, it's the mechanism through which you configure a lot of the deployment options for Coherence Web. So you'll make effectively entries in there for providing configuration options for Coherence Web. So make sure that you look at the documentation there if you'd like to effectively change locking policies and all these other features we've talked a bit about. Okay, so great. Hope you enjoyed the first part. This is sort of the lectureware here, and then in the second part, I'm going to effectively get down and show you an actual example application and deploy it. So stay tuned.